Now looking at problem 19, find the area and circumference of the circle below. Well, the first thing I want to do is find the area. And I'm going to write down the formula for every equation I use. It's a good practice to get into even if you know them. If you know them, it takes 2 seconds to do. If you don't know them, then it's going to help you remember by looking it up and writing it down. So area equals pi times r squared. And another thing I'm going to do is I'm going to go ahead and identify my radius and diameter. I'm given a diameter, which is the distance across the circle, so I will say d equals 18. And I'm going to identify my radius because my radius is half of this distance from the center of the circle to one side of a circle. So half of 18 would be 9. That's going to simplify things for me because now I can take that 9 and plug it into my equation. A equals pi times 9 squared. 9 squared is the same as 9 times 9, which would be 81. So A equals pi times 81. And you'll remember from class that we really like to see that more preferably as A equals 81 pi. It's just more professional to have that pi symbol on the right side, the same way we would have a variable to the right side of a numeric value. So if I were doing an exact area, which we've represented with an E, then I would take this solution right here, 81 pi. Because an exact solution is always going to have pi. Anytime I give an approximate value for pi, I change my exact solution into an approximate solution. So now I'm going to give an approximate solution, denoted by the A, and I'm going to multiply 81 times 3.14, 3.14 being my approximate value of pi. And that's going to give me 254.34. Let's call that centimeters squared. So we're done with area for this particular problem. Now let's go back and address circumference. And my formula for circumference is C equals pi d. And while I realize there was another form of the formula for circumference, I haven't focused on that for these classes because I really want you using one formula for circumference that focuses on diameter and a formula for area that focuses on using the radius. It's going to help keep those two formulas clearer in your mind. So C equals pi d. Well, we will carry that down and say C equals pi. We already identified d as being 18. Again, it's cleaner to have our pi on the outside, so C equals 18 pi. That's as simple as I can get that solution for an exact solution, so I'm going to call that exact equals 18 pi centimeters. Remember, the circumference is the distance around the circle, so it's not a squared unit. And now for my approximate. 18 times 3.14 is going to give me approximately 56.52 centimeters. Problem number 20. Find the area and circumference of the circle below. Again, I'm going to look for my diameter. I'm going to look for my radius. In this problem, I'm given a radius, the distance from the center of the circle to a side. So let's put that there. The diameter is the distance all the way across the circle. So if half of the circle is 2, the full circle would be 4. Now I'm going to deal with my two formulas again. So let's start with area equals pi r squared. Our r value is 2, so area equals pi times 2 squared, which would give me an area of pi times 4. Or more preferably, area equals 4 pi. So my exact answer for area would be 4 pi centimeters squared. My approximate solution for area would again take 4 and multiply it by 3.14. And that's going to give me approximately 12.56 centimeters squared. Now let's see what happens when we find our circumference. C equals pi times diameter. Well, my diameter was 4, so C is going to equal pi times 4. And again, we'll clean it up. C equals 4 pi. So my exact circumference is 4 pi centimeters. And my approximate circumference, 4 times 3.14, is going to be 12.56 centimeters. And you may or may not recall that we did a worksheet way back when we were first working with noticing the difference between area and circumference, that a circle that has a radius of 2 centimeters is going to have an equal value for area as it does for circumference. It's just one of the unique solutions for this particular circle. Problem number 21. Find the area of the shaded region for the circle, or for the square and circle below. Well, we have a circle put inside a square. First thing I'm going to do is find the total area of the square. And that would be accomplished by saying, well, this square is 12 centimeters high, and since it's square, it is also 12 centimeters long. So my square is 12 times 12, which equals 144 centimeters squared. Well, if the circle wasn't present, blocking out some of the shaded section, then we'd have a square that's 144 centimeters squared in shaded area. But that's not the case. We do have a circle there. And the circle, we need to calculate its area of white space and subtract that from the area of shaded space to find out how much remaining shaded space is still left in the square. So we're going to find the area of a circle by saying area equals pi r squared. And again, I want to know what the radius and diameter are. The diameter is the distance all the way across the circle. So if this measuring tool here was right in the center, then it would tell us, well, the diameter is 12 because that goes all the way across the circle. And since the diameter is 12 and we know the radius to be half of the diameter, my radius is 6. So let's plug that information into our equation. A equals pi times 6 squared. We are all getting good on our perfect squares, and 6 squared is 36, so A equals pi times 36. Clean that up a bit. A equals 36 pi. So we have all the information we need. My exact solution for this particular problem would be the area of the square, 144 centimeters squared, minus 36 pi centimeters squared. My approximate solution then takes 36 and multiplies it by 3.14. And I find my area to be, of the circle, to be 113.04. So now I can simply take my approximate value and plug it in for my exact value of the circle. So area would equal, or my approximate solution would be 144 minus 113.04, which would equal approximately 30.96.